In this video, I'll demonstrate how to run factor analysis with SmartPLS3. So let me first create a project, file, create new project and give a name to your project. And then you see here a new project has been created here. And this icon is for creating your model, and this is for loading your dataset. You double click it and load your dataset. I'm going to select my dataset here and then OK. So then you see the data is loaded here, and so these are the basic descriptive statistics of my dataset. So these statistics will appear only if data has been correctly loaded. Secondly, you see here the icon of the data will turn into green if it has been correctly loaded. Now let's look at some values which are a little abnormal. My data set is on a scale of 1 to 7, whereas I can see some values are little abnormal, 99. So these are in fact missing values. These are codes for missing data. So how should I tell SmartPLS3 that 99 is a code for missing data? So you see here there is one option, that is missing value marker. Just click it, none, and put here value of 99. And you see the missing value, earlier it was 0, now it's showing there are 8 missing values, and you will see so 99 values. So those values have disappeared now. Now I am ready to carry out the analysis. So just double click this icon, and so this is the space where we have to create our model. I'll use 3 variables in my dataset from my dataset for creating a model for running factor analysis. One is OC, and second one is JS, and the third one is OP. Here is OP. So OP is performance of the organization, and JS is job satisfaction, and OC is organization commitment. So what I do, let me give them names to the construct. So this is OP, and this is JS, and this one is OC. Now let me make little adjustments here. So right click and then align indicates right. And here what I can do, I can take it to the top and bring it here, and then indicates top. Here we go. So what I do now, I can JS to OC and OC to OP and JS to OP. Right? Now run it. Calculate, then consistent PLS algorithm. In step number 1, we have to check the option in setup. The option that connect all latent variables, and then go to partial least square, and here check the option of the factor if you're going to run factor analysis, and increase number of iterations to 1000. Just run it. So here we go. So these are the loadings. So the loadings indicate that the many values are fine, but some are problematic ones. As minimum recommended value is 0.7. However, if an indicator is having a value lying between 0.4 and 0.7, you have to carefully examine it. If its removal increases composite reliability and AVE, so then you can remove it. And if removal leads to decline in the values of AVE and composite reliability, then don't remove them. And look at here, so all these values are fine, and here in this case also all values are fine. Let me review report. So here is the report. So first go to factor loadings, and this is auto loading option. So you see, so GS1, GS5, GS7 and GS8, these are little problematic ones. Now let me examine AVE and composite reliability. Just click this option, so construct reliability here. So you see construct reliability is fine, all. So minimum recommended value is 0.7. So all constructs have composite reliability exceeding 0.7. So reasonably high, all are reasonably high. And alpha is also quite fine. And here in this case you see average variance extracted, minimum recommended value is 0.5, and all constructs have values exceeding the limit of 0.5. Now let me go to discriminability. In discriminability, first method is the Forner-Lorcan criteria. This method suggests that all values present on the diagonal side, so they are in fact square roots of AVE of the respective constructs, and values falling below this diagonal, so they are in fact correlation coefficients. For example, 0.794 is a correlation coefficient between the GS and OC, and 0.715 is a correlation coefficient between OP and GS. So this criteria suggests that, so this value means on the diagonal side, this must be greater than all values falling in the respective column and the row. So you see this 0.734 is less than this value. This is 0.794. And here in this case you see 0.742, so this is less than this value. And this is okay. So it means problem is somewhere in job satisfaction as well as in OC. And the second criteria, that is HTMT. So here it's satisfying the criteria as minimum recommended value is maximum recommended value is 0.85. So HTMT value for all constructs should be below 0.85. And now coming to here, cross loadings. So let me examine where is the problem as far as the Forner-Lorcan criteria is concerned, as that is not being, the condition of the Forner-Lorcan criteria are not being fulfilled. Just copy the data and take it to Excel and just paste it there. And then go to the menu bar and then conditional formatting and greater. So here we go. So first let's review the indicators values of the GS. So as far as GS is concerned, here is the problem. So the difference between, so GS4 is loading on the two constructs, GS as well as OC, and then if you look at OC4 also, that's also a little bit creating problems. It's loading high on OC as well as GS. And then rest is fine. So what I do in step number 1, what I do, I remove GS8 as its loading is little on lower sides, and also remove GS4 and OC4. So let me go to the model, and here first remove the item with the lower loadings in the GS. So 0.665, 0.662, yeah, this is the lowest one. So let me pick it and remove it. 0.662, Okay, fine, let me remove it and run the analysis again. Here's the algorithm, and so now this is also on lower sides, and this one is GS8. Yes, GS8. Let me remove it also. However, before you make a decision to remove any indicator, you have to assess its impact on AVE and composite reliability. Okay, so now let's review its report. So look at the discriminant validity and we construct reliability. So this is fine, no problem as far as that. Now coming to discriminant validity, and so some problem is there, still there in case of the OC. Now what I do, I go to cross loadings and copy it and take it to Excel, and then conditional formatting and greater than, and here so GS4, let me remove this one, and also OC4, as these two items are loading on the both sides. So GS4 and OC4, GS4 and OC4. Run the analysis again. Okay, yeah, looks fine, completely fine. Now let me examine the report. So outer loadings all are perfectly fine, right? And coming to reliability, perfectly alright. Coming to discriminant validity, 0.772, it is greater than these two values. 0.802 is greater than this value and this value. 0.836 is also greater than. So for an Larkin criteria is fully met now. Now coming to HTMT is also fine now. So construct liability and validity established. Discriminant validity has also been established. Now finally, let's examine model fit. Come here. So I'll use two indices. The first one SRMR and second one NFI. So you see its value is less than 0.08, so our model fit is established here. NFI's value should be closer to 1. It should be greater than 0.9. So that indicates that, so the both indices indicate that the model fit is established. So this is how we can run factor analysis. Thanks for watching.